automatically live. It's really hard for me to tell. Alright, that does appear to be live. Awesome. Okay, so this is just me sort of testing out whether I can stream, seeing how I like it, seeing if it's good for my workflow for game development. So I'm going to do something a little bit fun, maybe. I'm going to implement 2D lighting and shadows. So I'll show an example of this. This blog has like sort of a reference pseudocode for the algorithm, and you can play around with it. You can change your light source, change your polygon arrangement. So if you want to learn, what I'm doing, I'll sort of say what I'm doing as I'm doing it, but this is the general idea. I'm going to be retrofitting this onto my own engine, which is made in Odin using raylib for rendering. And my shapes, this sort of algorithm is built to work with polygons. I have both polygons and circles in my engine, so I'm going to need to cover both of those cases. But I have a few simple ideas for how to handle circles. So I'll show you where the game is right now. Right now it doesn't look like much of a game, but what we have, I have set up a shader which draws some rectangles into a texture, and then the actual game, we're only rendering the portion of the screen that is filled in on that on the second texture, which I'm calling the shadow buffer. So that part is done. We have a buffer to write shadows into, and so the next job is going to be drawing the right shape into the buffer. So instead of drawing two random rectangles, we're going to draw like this weird polygon shape, which is the visible area from this eye or light source, however you want to think of it. So first task, and it's the most fun one, so I'm doing it first, is draw the right visibility shape into the shadow buffer. Then I have some other ideas of ways to make this sort of fully featured. Well, I guess there's one other thing that is absolutely necessary, so I'm going to do it here, which is that if you notice, if we pause the game, the UI is under the shadow buffer, so it's that's not very useful. Because the easiest way for me to get this sort of post-processing effect of the shadow buffer is to just apply it to the entire output of the game. But I don't actually want to do that. I want to apply it to only the game world, right? This stuff, the objects in the game, and not the pause menu, which should be applied over top of it. All right, so I'll do that next after I finish this. Then I'm going to look up and sort of do a little digging on how to use the shadow buffer for colored lights, because at the moment it's sort of like the shadow buffer is going to be either white or black. Like in my version, either white, i.e. visible, or black in shadow. but we have 4 color channels to work with, so we can use like the alpha channel to indicate a 0 to 1 of like how in shadow it is. So if you, they're already sort of doing that here because they implemented some kind of like tapering away as you get farther away from the light source. But I was hoping to also do some color blending so that we can have like this light source which is yellow and then another light source which is blue, and then have the light interact in a way that looks natural. Okay, and then finally there's a technique that I saw in another implementation of this on Nikki Case's website, where here they have the same technique, but it's being used for basically controlling the lerp value, or the parameter of blending between 2 different textures. So they have like the shadow texture, which is the skull thing on black, and then the lit texture, which is this character on white, and then the amount of shadow determines the blend value between those 2. I think that's a cool effect, and I think that it would be useful to implement. So yeah, all right, those are my goals, and the first one I will do is drawing the right visibility shape into the shadow buffer. So I've kind of started this, but I ran into some kind of ugliness with my game's types, which I'm going to sort of hack something together, and then in a later pass I'm going to clean up the types a little bit. But okay, so I'll go into detail on the actual, like how the technique works. And I'll do that by reading one of these blogs. So the first thing you need is you have your point. You need to be able to pick a direction and then see what the first thing you hit in that direction is. That's called a raycast. And this is what this sort of like illustrates what you'll get if you just cast a bunch of rays, like 1 at each degree angle or something like that. You'll get shadows that almost work, but they're low resolution, and I think actually the other blog has a better illustration of what that looks like. So because you don't like this sort of like chunking effect happens because there's like a long period between when one ray like hits an edge versus the next one. So the rays tend to sort of jump in these big increments that don't look good. So what do you do instead? You only cast rays toward the vertices of your shapes, because those are the only places that things are going to change. Because of like floating point precision, if you cast literally right at the vertex, you might hit it or you might not. So to hedge your bets, you also cast like rays that are just offset from that one that's directly toward the vertex, which it says here. You offset them by a small angle, like an epsilon angle, and then so you have like 3 times the number of vertices, number of raycasts. You do all of those, and then you sort the rays in order of their angle, like it says here. So you sort them in order of their angle out from the point you're starting at, and then you draw a triangle between each adjacent pair of points, and then you're done. So you end up with 3 times the number of vertices in the scene triangles. You draw all those triangles into the shadow buffer, like this, and then that's your shape that you use to sort of mask that's your visibility shape. So that's the shape that I'm trying to get right now. Okay. Let's see. So let's see what I have done so far. I think the first thing I'm going to do is just test my helper functions for raycast. So I have two types of shapes, like I said. I have polygons and I have circles. Now, if we look at this, they only have polygons. So how are you going to extend it to circles? Well, the idea is you take your circle and you figure out the tangent points to the circle. As in, here is a circle, here's your point. You want to figure out the points on the circle that form tangent lines with the original point. So, and these are the equivalent of the vertices. Now, of course, what you're going to get there is some kind of like triangle like this, which still includes part of the circle, and I have a way to deal with like keeping this part of the circle in shadow also, but we'll get there when we get there. So for now, I'm just going to test that this works. So let's go ahead over to my renderer and turn off the shadow buffer for a second, because right now I'm just going to do some debugging. Okay, make sure our build process works. Yep. Reload. And now we should see. Uh-oh. Maybe I was testing. Interesting. Yeah, of course when I stream I get a new error. Okay. Whatever. So here's the game. It looks kind of jank. It's like a test game to demonstrate all my engine features, and it's not a real game. It's a development game. But we've got our hero, Potato. He's called Rotato because usually he rotates. Right now he's not rotating, and that's on purpose. You can push around these other potatoes. You can click and drag these things, whatever. It's a game. If we look at the debug stuff, you will see the hit shapes, the collider boxes. So all of these are polygons. I'm going to have like a source of light here, and it's going to bounce off of get blocked by all of the polygons of these things and the polygons of the walls. And that's my current goal, is just draw the right shape there. But in order to do that, we're going to test these collide helpers. So the way these are supposed to work is you have a ray, which is like a ray is a position and a direction or velocity, however you want to think of it, and a line segment. A line segment is a type alias for 2 points, right, A and B, that the line goes between. And what you're trying to get is the distance. This is the distance in direction of line until hits, and then does it actually hit? Now, oh man, the Odin formatter is really rough there. All right, whatever. So, okay, so I have these filled out, but I need to test them to make sure the math is right. So what I'm going to do is in lighting, which is where I'm mostly going to be working, I'm iterating through all these objects and getting the raycast direction. So I already have a list of rays, which is like everything toward all the vertices and then slightly rotated in either direction, like we said in that blog. So now I have a list of rays. So for direction in raycast directions, for each one of those, I'm going to just draw a debug line between let's see, where am I starting from? This P, right? This is my like light source or camera or whatever, like eye position. P plus dir, and I'm gonna draw it in orange, and I'm gonna do thickness of 3 to make it really obvious. Looks like we have an imported raylip. That's fine. Import RL render raylip. Okay, cool. We're gonna not do that. We need to return some dummy value so that we can test it. And now I'm going to call this from somewhere. So maybe I will call it from render, somewhere near the beginning of render. Eventually I'm going to call it in the very end of render. So this is a defer block, which means it happens after all the other stuff's done. So we're going to defer. The way the render works is like you're going to write into this viewport texture, then you do all your drawing your objects and everything, all that rendering the game, and then you're going to defer doing this thing, which actually stops writing to the texture. This is writing to the shadow buffer, and then we're going to rescale the texture to the actual window. So this is how I handle like viewport being different from window size. And then we're going to start drawing the viewport texture. So just in one image, you put the game on the screen in the right place. It's rescaled to handle like the screen being a different resolution from the viewport. Okay, and then so in particular, you make the shadow texture here, the shadow buffer. So in the final version, we're gonna get the visibility shape of like the player, or for all the lights or whatever, and then we're gonna put them into the shadow texture, like draw the shape, whatever. But for now, in the interest of getting something onto the screen, I'm just going to call this earlier. I guess whenever I do the debug stuff. Yeah. Actually, it doesn't matter when I do it, because drawing the debug lines is deferred until the end, so I can just do it here. Okay, so we're gonna just get a visibility shape. Let's see. I think that we need to add a parameter here for accept. Let's see. Exclude maybe game object handle. Okay. Equals no. All right. So the idea here is I'm going to cast a light out from the main guy, right? But it's going to be here, and the main guy has his own polygon, so we want light to just pass through that polygon in particular. and hit all the other ones. Otherwise, we're just going to block all the light, and it's going to look like terrible. So exclude, I guess, exclude equals, let's see, rotato.handle. All right, now we're going to be calling it. So let's see what it looks like. Could be a disaster. Who knows? All right, reload. And what do we get? Let's see. How do I get that? Interesting. Very interesting. Maybe I need to add an error check, if okay. I'm going to do this. I'm not going to use the result. Okay. All right. So this is kind of interesting. This is showing me I'm drawing like some of the right lines, right? I knock these around. Okay, I kind of see what's wrong. So I'm sort of pre-optimizing. So instead of iterating through chunks, I'm just going to iterate through all the objects. Like whatever. So I'm not going to do chunks. That comes later. All right. So optimization. Only look at objects in chunks near the light source. But we don't need to do that yet. So forget chunks. We're just going to do iteration over all objects. For object in all objects with variant, or no, with tags. Iterator collide, because those are the ones that have hitboxes. And then we do the same thing that we did here. Okay. Then we need to take this math and put it here. And then we need to get rid of this. All right, so now it should be slower, but it should work. I haven't reloaded it. Okay, now we're drawing a line, and it does in fact look like it's going accurately to these vertices. Now let's do the raycast. And actually, let's see, where am I drawing that line? I'm going to make it thinner. Let's take a look at that. All right, there we go. So let's say if obj.handle equals exclude, continue. Okay. Let's see. So next, let's do raycast. So basically, I'm going to make another version, which is ray versus polygon. So get distance to collide ray polygon. 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 Okay, same signature though. And then the idea is for each vertex in the polygon, we get a line, which is a line segment that connects V to polygon transform vertices at the next one in the cycle. So I plus 1 mod length of polygon depth transform vertices. Okay, so that's a line. And then we say, we call our subroutine ray line. Okay, if will collide, then we need to keep track of the minimum, so min distance equals the biggest possible then min, actually what am I doing? Min dist is equals the min of d and min dist. Okay. And then we return see. The overall will collide is just, did it collide with any of them? So I guess we can just do that, and then will collide side, and then we're going to where's the pipe? There it is. Or equals will collide side. Okay. Yeah. Return in dist and will collide. You can do a naked return if you want. That's this, because you've named the return variables, but I don't like doing that. In fact, it's going to be wrong. D side. All right. Okay, so that's a ray polygon. Let's do get distance to collide ray scene. I guess ray scene. This is sort of temporary because later we need to also take into account the fact that this can be a circle. Okay, and this will again call subroutine. So we're going to start with min dist. Let's see. Actually, I'm not going to have a separate variable this time. So you start at max. Oh, and that should not be F16 max at all. We're doing 64. Okay, and then we just do another for loop. So for poly in polygons. All right. And you return D and will collide. Okay. So here is where I want to do my debug. So I will draw a debug line from ray.position to ray.position plus ray.velocity, and then we're going to normalize that. Because this is a direction, I don't enforce that it's a normal vector already, times d. And actually I'm going to do that right here before we return. And I'm also only going to do it if the ray collides with anything. Alright. So now we just need to go call this somewhere from like here. So I guess what we'll do is we will, in addition to getting the list of rays to cast out, we're going to get a list of polygons, and then construct it and pass it in there. So we're going to make a bunch of polygons. We're going to, if we encounter a polygon, then we're going to say polygons in the scene dot append shape. Hopefully it's able to just copy this. I don't know. I might want to do sort of a clone. New clone. Okay. Clone is this. Don't care about that error. Okay, what don't you like about that? This gives me a pointer. That. I don't know if I need to do that actually. Let's just see what happens if I don't. Just kind of preempting stuff. So I'm going to put that in polygons in scene. Okay. And now instead of just drawing the direction, we're going to call get time, or I guess distance, and will collide is get time, or get distance, sorry, to collide ray scene. And then the ray is going to be from P to direction. I think I'm already subtracting the original point when I do this. Okay, and then you're going to do ray and polygons in the scene. Okay, you don't know what that is, it's a ray. Alright, let's see what happens. Probably something bad. Alright. Well, that's sort of interesting, isn't it? It's definitely like stopping at some shapes, but the shapes are seemingly mirrored, which is kind of fun. You see that? So like the mirror image of the shape is where the rays are stopping. That's really interesting. Okay, fun. Let's see why that's happening. So it must be that D is getting returned as the negative. That would sort of cause that to happen. So let's see what this looks like. looks a bit better. So let's see. A few things to sort out here. First off, I'm not... Ooh, what's up with that? How come when I leave, it's not drawing the rays anymore? And yeah, it's still drawing them in the wrong direction. Let's see. Some things to sort out, I guess. We're drawing... Like, the rays are stopping on the right box. But I should... Like, I'm definitely seeing some corners that I'm not shooting rays to. That I should be. Okay, so the ray directions are wrong. Pretty sure. Like, yeah, okay. Probably easiest to figure out just why did they go away when I walk over here. Like, why am I not shooting towards anybody right now? What I'm expecting this function to return is a small positive number, right? I think it might be doing negative numbers, in which case I need to do, like, you know, start at the S64 min and then take the max here. Just feels silly. All right. So let's look at this. Okay. So what are we doing here? Let's see. I guess let's look at ray line segment, right? So let's get a sketch pad over here so I can draw out the situation. Okay. So undo all this. We got A and B. We're getting a segment which is B minus A. This is called seg. We got the perpendicular, which is, I guess we also have a ray here. So a ray has a position and velocity. Okay. We get the perpendicular clockwise to ray direction. Clockwise is this way. So this is the velocity. This is perp. Okay. We're going to dot this segment with perp to detect whether they are parallel. If they are parallel, is that even right? Right, because it's AB cosine theta. I don't think that even works. I think they're wrong. I will have to level with you. This is vibe coded. Just the implementation. I did the signature and then I asked it, please implement it. I can get into the math and do it myself, but I prefer to check math that's almost right and fix it. Okay, so whatever. I'm ignoring that because it never happens. It's supposed to detect the parallel case. It might actually detect the perpendicular case. Okay, so we're going to subtract ray dot position minus A. That's this one. Okay. We're finding T, which they're trying to do cross of segment and this vector V. Okay. this two-dimensional cross product. Okay, divided by this denominator, which I was kind of curious what the point was. My understanding is that if the ray is like directly heading into the thing, then the perpendicular will be directly parallel. And if you do a dot product between this guy and this guy, it should be like, it shouldn't be 0. This dot product should be 0. Like they're kind of fucking up some linear algebra. Like, why don't you just... Okay, we'll figure it out. So, anyway, you're taking a dot between this guy, V, oops, V here, and perp now. And so you're taking a cross and a dot. Interesting. So T usually indicates like how long it will be. Actually, the dot between this guy and perp makes sense because this is figuring out let's see, why do you need between 0 and 1? Why do you need between 0 and 1? That doesn't make any sense. All right. Jeez. That's why I should have done the tests for this first. Or like, you know, actually copied an implementation from somewhere. Ray line segments intersection. Vectors. All right. This is probably what it's doing. Okay. I don't care about triangles. All right. So, ray origin, ray direction, 0.1, 0.2. Okay, this is person's doing the same thing. They say they didn't consider the parallel thing. I don't really care. I can handle that. But in the normal case, this is their algorithm. So you do ray origin minus 0.1, 0.1, 0.2, ray origin, ray direction. Okay, so ray origin minus 0.1, 0.2 minus 0.1. Okay. Okay, you're doing the perpendicular thing. Sure. You're again doing V2 dot product V3, which is V2 V3 to detect this. Okay, you do a cross product divided by the dot product. All right, same thing. So, okay, it seems to have basically copied, wrote an example algorithm. I'm going to assume that this is something to do with like a half space check. Because there's always a thing of like, if you just have like two lines rather than two rays, if you have just like an unbounded line and a line segment. Oh wait, no, I know what this is. This is like, does it hit between this endpoint and this endpoint. So like if you were doing like line versus line, then you know any two lines in a plane are going to hit somewhere, unless they are collinear, which is like the annoying case. But they're going to hit somewhere, and then you need to tell, first of all, is this point greater than like the start of the ray in this direction? And also, is it inside this segment? So the t less than 0 means that like the line was back here. And so it did hit along this line, but it didn't hit along this ray. Okay, and then u less than 0 means it's over here. U greater than 1 means it's over here. So all of these things have to be false, otherwise the collision didn't happen. Okay, so I trust this now. And I am guaranteed that it's returning t, which is in multiples of the ray velocity. And that's a positive or 0 number. So this value is positive. Okay. Which means that the thing that I care about is still, or this is still correct, right? Because we're getting little positive numbers out of here. So we start at the biggest positive number, we get smaller and smaller until we get the closest line segment on the polygon. Okay. And that means I basically trust this also. So I guess my question is, where did we get confused here? And get like a negative number. Right. Okay. So let me look at the output here again. All right. So I think this was the version where I did like, I tossed a negative sign in there to make it look right, but of course that's not right. So now I think I'll go ahead and put a debug point there. Or no, not yet. All right, so just to make sure, this is the one that looks all mirror imaged. So if I go this way, do I ever stop drawing lines? I do. It must be that they didn't collide. Let's see. Like, okay. Let me just draw it regardless of if I collide or not. I just want to see what happens. I still stopped drawing them in this direction. That's very weird. Okay. So, at the end of all this, when I'm like drawing the line, what is D? Now I'm going to look at the console here. So D is a positive number, and it looks to be sort of a realistic amount of distance in pixels. Okay, my FPS is suffering there, of course. I'm trying to do all these console logs. All right. Okay. So what is happening here? So I'm drawing from right position, plus that, which is the unit vector version of velocity, times the distance. I guess this is not named correctly. Okay. What's going on? Could be the sort of like copying over the polygon thing that I mentioned earlier and then sort of brush past. Right? If I append this shape, I guess no, it's fine. I don't change any of the shape stuff, like the transformed vertices, between when I do this and when I draw. Okay. So how did it become backwards? Okay. Okay, so that with this version, it does look as though I am at least casting the right number of rays in each direction, right? When there are more objects on this side of the guy, I'm casting more rays in this direction. They're just somehow like flipped. Okay. See that? Why are they flipped? And also, like, okay, look, I'm casting a ray directly to that guy's corner. So they're going in the right direction. I'm just, the result that I'm getting is like the negative of the actual distance. Okay. Yeah, because I did confirm before I did any of this raycasting stuff that when we just draw the straight up lines to corners, they're the right lines. Okay. And if I was getting negative numbers, I would have already seen that, because the min dist would be like a big negative number. So I'm pretty sure that like getting positive numbers is right. Am I missing something about how normalize works? V over length V. Yeah. Okay. Let's draw it a different color. That'll make me feel better. Oh, of course. All right. Wow. It's pretty bad unoptimized, but it'll get better. All right. Fun times. You see, like, I'm pretty sure casting the vectors in the right direction. I'll see if okay. I'll just have fewer potatoes. It'll be easier to see with fewer potatoes. So let's do 10 potatoes instead of 100 potatoes. Okay. So all right. Something is weird here. I think I must be. Am I using light radius? No. Okay. Okay. Yeah. Now it looks way more wrong. Okay. I should just draw more things. Draw a debug line between ray.bonds plus ray.devel rl.orange. Let's see what happens if I just draw the ray. Right? Okay. So that is going straight to. Let's put potato back here. What are you drawing to there? That's weird. So this is just drawing. Oh wait, no, I do know what it's drawing to. It's drawing to the tangent points of this, except it's in local space because I haven't gotten to that yet. Forget it. So the orange lines are right. Orange lines are right. If we'll collide, then we'll draw the red line. You don't know what linalga is, that's fine. Okay. Then we will stop drawing that. Theoretically, this is the same thing. Okay. So I guess maybe it's bugging out when it tries to draw a line that's like F64 max long, because if you never collide, then you're just going to end up with D being that. So that could pose a problem. Just a weird little bug, or weird little edge case that Raylib doesn't handle that well. This is already if will collide, so Okay, there's got to be a sign error. There's got to be a sign error somewhere. Okay, I will start writing tests. I'll stop trying to guess. This is what I always do. I try to guess the problem just sort of intuitively, right? I look at the output and see what's broken about it, which leads to me through some like really abstract trains of thought that sometimes go nowhere. And that's fine. Sometimes I debug it, sometimes I don't. If I spend too much time in an abstract train of thought like this, of like, what's the qualitative way in which this looks wrong, then I will give up and I will start writing like simple tests. So let's write a simple test. I'm going to do assert. So basic tests. Ping. Guess I don't check pings on stream. I'm glad that I checked that ping. Let's see. So our line segment is between 1, 1 and 1, -1. Very simple test. Array is array going from 0, 0 in the direction 1, 0. Assert that get distance to collide ray line segments ray line is 1, because after 1 horizontal distance, I guess, let's see. I guess D and will collide, right? Equals that. Assert will collide and D equals 1. Okay. Hopefully, I was hoping that would just immediately tell me what the actual value is. Okay, it doesn't think it will collide. Very interesting. So maybe the sign error is all the way back here. Okay. Like, for example, this. Just a guess. Because How did I know? How did I know? Okay. I have provided both perpendicular clockwise and perpendicular counterclockwise utility functions for myself. However, AI is stupid and, well, relatively. And even though the standard definition of rotation, get the perpendicular thing, is to do it counterclockwise, it just found the first one and used that. I think this is what happened. So, let's bring back the 100 potatoes and see if we're good now. Game, 100 potatoes. Yep, looks fine. Okay, and then let's go over to lighting and stop drawing the orange ones, only draw red ones. And actually, draw them all the time. I want to see what they look like. Okay, that looks correct. Hooray. I'll see if I can figure out the thing with, oh yeah, and also, we're still drawing the lines in the right direction when we move away. All right, so this is pretty bad performance. I'm gonna get rid of this little test because it helped me find the issue successfully. And I'm gonna get rid of this in order to see how bad is the performance without all my debug stuff. Like, how much is this gonna cost me? The answer is not that much. This is about the same as the previous performance. I will have to draw a bunch of polygons. Like, I'll draw polygons on the order of the number of shapes. I can probably do some optimization to, yeah, I'll write that down actually. So there's another optimization. Remove polygons which start and end on the same side. Remove, I guess, viz shape polygons to be more specific, which start and end on the same side of an object. And that'll reduce the number of like draw polygon calls I will need to send to Raylo. Okay. So yeah. Sometimes you'll see lag spike, and I'm 100% sure that it's OBS. That's OBS's fault, because when I turn off OBS, it goes back down to like the ambient level. Okay. So, all right. So we're halfway to this. So we have now like get the points of the weird polygon. Draw the weird polygon into the shadow buffer. So this is now done. Now we're going to draw it into the shadow buffer. So let's go ahead and do that. So what we want to get here is if dist is greater than light radius. So we're still going to end for the points that didn't hit any objects. The distance we're going to return is like giant. I guess what we can do is like if you won't collide, because that's the situation in which this happens. This equals light radius. Okay. Now the point that we need to add to the polygon is going to be p plus dir times disk, which is what we just drew. So I guess what we can do is like make a list of points and then do this little calculation for each of them, just to avoid calculating that twice. All right, so that's what we're gonna do. And actually we can kind of reuse the raycast thing. Raycast points. To avoid reallocating, we can just assign here. So for each that, we're going to say that. I hope. Or we can just do that, yeah. All right, so now we're just assigning back into the same slot in raycast points. Okay, and now we can do raycasts. This step is get list of objects to raycast against and directions to raycast in. This is do the raycasts, and then this is assemble polygon from raycast results. And this is the pseudocode that I had before, whatever. Okay. So polygon, I guess, yeah. Yeah, I guess it's a polygon. What am I returning here? Oh, yeah, okay. Visible regions. I'm making a dynamic array of visible region. Okay. All right. So for each point and index in raycast points, we're going to do. We're going to make a triangle. And it goes P, I guess we need to call this point because P already refers to like the center of the entire raycast, like where the player is. Point. Next point is going to be raycast points I plus, the whole deal. I plus 1 mod length raycast points. Next point. And then we're going to say this is a triangle, and then we're going to say visible regions dot append try. Okay, and now visible regions. Visible region is a struct that so this is like the points which are lit, the circle which is in shadow. So basically the idea is what we've done so far is just like ray versus polygon. But let's say that we have a circle in the scene, like this. What we want is to draw this triangle. So we're going to compute like this triangle, which is in the light, but we don't want to draw this part. So we're going to save what this circle was. Like its start is here, and then its radius is that. And then we're just going to draw the triangle and then draw the circle made of shadow over top of it. So it will cut out this chunk and put it back in shadow. And then the thing that we end up drawing is like this, as opposed to just a normal triangle. And then we get the perfect visibility shape, and it handles both triangles and circles. So, handle circles, by the way, is the next step of this. All right, so the upshot of this is visible region. The triangle is is that, and then the circle is nil, because we're only handling polygons. Okay, we return visible regions. And I'm going to assume that this is scoped to the frame, actually. So I'm going to put it in the temp allocator, which means it'll get cleared at the end of the frame. Okay, now we have these optimizations to do, we've got circles to handle, but for the moment this will pretty much do what we want. So let's get it. Do this. Draw, I guess rl.draw triangle. We need to cast them, I guess, draw debug polygon. No, that's not very good. Wait, just draw a debug polygon, handle like world space. Yeah, this does, okay. So just for quick and dirty, I'm gonna abuse my power. Shape that triangle. See, what do I do here? Yeah. So for what the reason that I'm doing this, by the way, I haven't really explained myself, is my mission here is draw triangle for a shape in world, in screen space, right? But the triangle that I'm handed in is world space. That's what we just assembled. So this shape has a triangle in it, which is in world space. So I need to do this world to screen space conversion, and the draw debug whatever stuff eventually does do that. So just being lazy, right? I will draw a debug polygon now, which probably doesn't exist. Yeah, fine, whatever. I'll do it properly. I'm trying to be all lazy and stuff. So what I need is steal that world to screen conversion. So we're going to do draw triangle. conversion. Okay, what's your, and then you do rl.white. Okay. Amazing. So I don't know if I turned it back on. No, I didn't. But let's see what that does. Something bad. Why are we back to this? Oh, yeah. Okay. Because I need to call it the same way as it was. Yep. Then I move this stuff into here. Rotato present. Rotato present. Then do all this shit. And then also, if rotato present, if and only if that, do this. And then do that. All right, so now only when the player has spawned and not on some first frame before spawn has run, we will do the shadow map texture. Okay, let's see what this looks like. Should be pretty cool. Well, that's interesting. Some sort of conversion is wrong, evidently. Okay. I think it's doing the right shape. It's just blown out by like a huge amount, right? Like maybe screen conversion is wrong or something. Let's not do a world to screen. Maybe I don't need to do that. That'd be kind of fun if I'm already doing it in screen space somehow. Who knows? Nah, that ain't it. That ain't it. Okay. Pretty sure that's necessary. Yeah, all right. So let's print out what this visibility shape is because I never actually checked. Let's say, right, so I'm going to do this, do that. I'm going to, after I clear the background, call the thing, and then we're going to draw, debug, polygon, shape, dot, triangle, dot. That, does that work? Not quite. I need to do like this to make it a slice. Why doesn't that work? Okay, that's what I did. Value is not addressable. Why the fuck not? Okay, so now we're going to be drawing some debug polygons. See what happens. Okay. Let's stop drawing those lines, I guess. I think I already did stop drawing the lines, actually. Right. Yeah, I did. Okay. So... Oh, I never sorted them. I never sorted them. That's why. That'll do it. Okay. So, yeah. So sort dot. Yeah. I forgot a big piece of the algorithm. So sort raycast directions by incident angle. Slice dot sort by raycast points. And what I need a sort of some kind of comparison function. So what is it? It is the arctangent it's arctangent. So get incident angle is a proc that takes a point and a direction, which of x, and gives you double f64. So we're going to return math.a tan2. Probably need to import core math, so we don't use this anymore. All right. So the difference is direction minus p. Or no, it's just the direction, isn't it? Yeah, I don't care about p. Yeah. So math.a102 dir dot y dir dot x, which goes... Actually, I don't know what the order is going to be, but it should be like circular. Sort by key. Yeah, that's correct. So get incident angle. Okay. Well, I guess I got to turn off shadow buffer for a second. Because I'm still drawing this rectangle. And yeah, just don't do that. I'm trying to debug for a second. Okay. So, does this look right? I don't know. No, it doesn't. The lines are going past where they should. Potentially. Yeah, those lines definitely shouldn't be continuing through the shape. Okay. make sure I'm returning the right stuff. It definitely looks different. Okay. Just gonna draw it. Just gonna draw it. I guess here. I don't care about all the ones going between the point and the like the center point. I'm just gonna draw from point to next point. RL dot light something or other. Whatever. Red. Why aren't you doing it? Why aren't you doing it? Alright, thick yellow lines should be occurring. If they're not, we're in trouble. We're in trouble. Where are the thick yellow lines, huh? Points. Alright. I have a slight worry that these points are just off screen. Yeah, that's correct. So let's make sure it's the right shape. Something kind of weird about this. Yeah, I don't think the sort's doing it correctly. Something wrong with that sort. See, like, why is that a point? Yeah. Okay, something's wrong. So, okay. Let's do a sanity check on the sort. Get incident angle 0, 1, 0. Equals 0. Assert. Get incident angle. I guess let's do sort of a math dot 2 degrees of 64. 0, 1 equals 90. Okay, so all right. So this I think is fine. Negative 1, 0, oops, 0 equals 180. I'm gonna check the stream actually, see if anybody's ever been in there. Somebody looked. It's kind of fun. He looked for a second. Okay. Okay, I'm gonna hunker down and figure this out. Not live streaming, because as fun as it is to voice my thoughts, I think I need to do some thinking in silence about this, which will not be as fun to watch. So I'm gonna turn off the stream and